Okay, let's just dive right in. The Kubernetes Gateway API, it's incredibly powerful, right? A huge step up for managing traffic. But if you have ever used it in a shared cluster, you've probably felt this hidden tension. It's like a quiet tug-of-war between the folks who run the cluster and the folks who build on it. So in this explainer, we're going to pull back the curtain on that very conflict.
So here's our game plan. We'll start by really defining this tug of war, then we'll pinpoint exactly where the friction happens, right there in the config files. After that, we'll look at the, frankly, painful problems this creates, explore the new solutions designed to fix it, and wrap it all up with a clear action plan for what an ideal setup actually looks like.
So, who exactly are the two sides in this battle for control? It's time to meet our players. All right, this slide really gets to the heart of it, doesn't it? It just lays the whole conflict bare. So on one side, you've got the cluster admin. Look, their whole world is stability, security, predictability. They need to be in charge of things like ports, because if they're not, the entire cluster could just fall over. But then, you've got the app developer on the other side. They need to ship features fast. They need autonomy. They need to control their own certificates for their own domains. See the problem? Both sides have totally valid needs, but they're pulling in completely opposite directions. And that's the real paradox here. The Gateway API was designed to be way more flexible and expressive than the old Ingress resource. And it is. But in doing so, it kind of inadvertently mashed these two very different worlds together into a single object, creating this really awkward power dynamic that honestly wasn't there before. So let's get specific, because this friction isn't just a concept. You can literally see it right there in the YAML. This is where a single configuration file becomes a battleground.
Okay, think about the really core infrastructure settings, like opening up port 443 for HTTPS. This stuff is clearly the admin's turf. I mean, you absolutely do not want application teams deciding which ports are open to the entire internet. That is the cluster admin's domain, and for very, very good reason. It's all about stability for everyone. But inside that exact same configuration, you have the TLS certificate reference. Now, this part is almost always managed by the application team. They own the domain name, they're responsible for rotating the cert, and they need control over it to deploy their service. So here's the crucial point. You have two different owners with two different responsibilities, all jammed into one single resource. And this whole messy situation, it's got a perfect name for it: permission spaghetti. You know exactly what I'm talking about, right? It's that tangled mess where you just can't draw a clean line and say, this is yours and this is mine. If you give a developer permission to edit this one file so they can update a certificate, well, you've also just handed them the keys to change the port number. And yeah, that is a recipe for a very, very bad day. Now, this permission spaghetti isn't just some theoretical problem. It leads to real daily operational pain and some, let's just say, very messy workarounds. It basically leaves platform teams with two terrible choices. Option one, you give developers access and just hope they don't accidentally fat finger a port number and take down a critical service. Or option two, you lock it all down, and now your developers are completely stuck filing tickets and waiting for an admin just to do a routine certificate update. Neither of these scales, and trust me, neither makes anyone happy. So, to escape this awful choice, teams turn to policy engines like Open Policy Agent or Kyverno. Now, these tools are powerful, don't get me wrong, but let's be honest, it often feels like you're just bolting on a safety net after the fact. You're writing these complex policies just to surgically slice up permissions that really should have been separate in the first place. And this quote from a cluster operator just nails it. The workarounds, they function, sure, but they feel fragile. It takes so much glue logic just to hold it all together, and that complexity becomes its own form of risk. This is a super common feeling out there in the community. Okay, enough about the problem. The good news is the Kubernetes community totally recognized this pain, and there are some really interesting solutions emerging that are designed to call a truce in this tug of war. Let's see how they build a better way forward. So the first and most official solution is called ListenerSet. Now, it's still experimental, but it does one simple, brilliant thing. It pulls the entire listener section, including that tricky TLS configuration, out of the gateway object and puts it into its very own resource. And this right here brilliantly illustrates the change. Before, you had this one big monolithic object where all the responsibilities were dangerously mixed up. After, the roles are decoupled. The admin owns a slim, stable gateway object with just the ports. And the developer owns a completely separate listener set where they can safely manage their certificates without ever being able to touch the underlying infrastructure.
It's just clean. This quote from Gateway API maintainer Nick Young gives us some fantastic context. The original design made a lot of sense back when certificates were expensive, rare, and managed only by central IT. But now, with tools like Let's Encrypt and Cert Manager, that world is pretty much gone. ListenerSet is basically an evolution of the API to reflect the modern reality, where developers can, and probably should, manage their own cert.
But that's a fair question. For some organizations with super strict security postures, giving developers direct access to secrets, even through something like ListenerSet, is just a non-starter. So what's the alternative if this model doesn't quite fit your company culture?
Well, this is where the custom operator pattern comes in. It's an even higher level of abstraction. So a developer defines what they need in a super simple custom resource. Maybe you call it a tenant route. Then a controller, or an operator, it watches for these objects and automatically translates them into the full, complex, and secure gateway configuration behind the scenes. The developer never even touches the sensitive fields. And this quote from someone who actually built one of these operators gets to the very heart of it. The whole goal is to create a clean, simple API surface for your developers, your tenants, while the infrastructure team keeps total control over the really sensitive parts of the configuration. It really is the best of both worlds. You get developer autonomy and infrastructure stability.
So we've seen the problem and a couple of really powerful solutions. But how do we put this all together into an ideal setup? Let's look at some actionable lessons from teams that are out there on the front lines.
Okay, so here is your action plan. First, you have to formally split responsibilities. Admins own the gateways, developers own the routes and their certificates. Period. Second, automate certificate management, because doing it manually is a huge source of pain. Third, seriously consider using custom resources to hide all that complexity from your app teams. Fourth, always start with the principle of least privilege. And finally, standardize your gateway classes. Those are the templates for your gateways, so that the behavior is consistent and predictable for everyone.
As we start to wrap up here, it's worth just zooming out for a second. The whole reason solutions like ListenerSet and custom operators are even necessary is that Kubernetes, at its core, doesn't yet have a perfect native separation between the concerns of the people running the cluster and the people building applications on top of it. And that kind of leaves us with this final provocative thought. These new patterns are a massive step forward, for sure. They provide the guardrails we desperately need. But until that fundamental separation of concerns is truly solved at the platform level, are we all just carefully writing our YAMLs, building our abstractions, and kind of hoping that nobody on the other team accidentally steps on our toes? It's definitely a question worth thinking about.